So this problem deals with the convergence of or divergence of the series from n equal 1 to infinity of cosine n pi over square root n plus 3. So I put it under the alternating series test, though I mean, when you look at it first, it doesn't sound like it is alternating. We don't see the minus 1 to the n. And there are many problems like this where the minus 1 to the n is hidden. The alternating sign is hidden. Okay, it's there, but it's hidden. And that's the case in this problem. So what we need to do to use is we need to get some help from trigonometry. Okay, it tells us that cosine of n pi is minus 1 to the n. So the series now cosine n pi over square root of n plus 3 is in fact the series minus 1 to the n square root n plus 3. So now we can see that the series is alternating. Okay, is alternating. The sign is alternating. Okay. So in this case, we can try to use. It is obvious that the series of absolute value. Okay, so if we take the series of absolute value, so here if we're gonna check for absolute conversions, okay, and we take the series of absolute value, we're gonna find sigma 1 over square root of n plus 3, and the 3 there shouldn't be there, so we know that square root of n plus 3, right, is equivalent to square root of n when n is large. So we can use the limit test. We have positive series, so we can use the limit test. So first, note that 1 over square root of n is divergent by the p-test, because 1/2 is less than 1, and therefore the series 1 over square root n plus 3 is divergent by the limit test. So this series of absolute value is divergent, and therefore we have to use something else, and that's why we're going to use the alternating series test, because we have minus 1 to the n over square root of n plus 3. So we're going to try to use the the alternating series test. So here, of course, if we take the absolute value, okay, this is equal to n plus 3, so we have to check two things. We have to check that it goes to 0 and is decreasing. It goes to 0, that's obvious when n goes to infinity. And of course, since n plus 3 is increasing, square root is increasing, and 1 over square root is decreasing, therefore is decreasing as well. Okay, so the series minus 1 to the n over square root of n plus 3 is convergent by the alternating series test. It is conditionally convergent because its absolute value is divergent.